of you. Okay, so guys, we are starting today with a new topic. The name of the topic is VPN. So as know, VPN stand for Virtual Private Network, right? So what is VPN? What is the importance of the VPN and why we need it, right? So let's discuss all these points one by one. So before that, we need to understand like how we were sending the traffic to the internet. Like we did many things without VPN, if you remember, on Cisco Firewall. So normally we forward the traffic from LAN to WAN for internet services, right? Internet services. So in that case, we are using here normal configuration. And what kind of configuration is required here? If I'm giving you idea. So suppose we have here user in the LAN network. User is connected with a firewall, right? So this is Cisco Firewall, and here we have internet. And now if user want to access any kind of service, like maybe we have here some servers on internet that we are using, or any URL. So if user want to access, like user have IP address 10.1.1.1/24, gateway is 10.10, and here we have public IP 102.1.1.1, right, on this interface. So now what we usually do, we configure the NAT configuration on the firewall, and we give here one default route so it can reach to the internet, right, without any problem. So whenever user is sending any data, so user is trying to access maybe any server, like this is your DNS server 8.8.8, right, and this can be any Google server or something for me, google.com. So whenever user is sending data, it will add its own IP address, and the destination is like IP address, maybe the DNS IP address if there is DNS query, and maybe it can be the IP address of the Google server as well. So when the traffic is hitting on the firewall, so firewall is receiving the traffic on this inside interface, and here is the outside interface. So when traffic hits on the firewall, firewall do the net translation, right? So normally we net, like I want to pat this entire network in a single IP address 102.1.1.11, right? So that means now my entire data of the firewall will be using this IP address as a source IP address because of the pat configuration, and the destination is 8.8.8, right? So in this traffic flow, like we are just changing the IP address, there is nothing like encryption. So this is like normal data. This is normal data that we are putting on the internet. So when firewall will send this data to the internet, so if anyone try to check what is the data inside the packet, so it will visible clearly. Like here we have layer to layer. Okay, so if anyone try to capture and look into the data, so it will just show you clearly what type of data it is, like the destination IP, source IP address, and the other parameter in IP header, and maybe they will check even the data, right, if they check. So this is normal data that we are trying to send from LAN to WAN, right? But maybe we have multiple type of data in that case. Okay, that need some specific required configuration. So what type of requirements do we have, guys? So the first thing is, maybe we have multiple type of requirements, like we need communication between the branches. So like there can be big organization, right? So in big organization, they have multiple offices and locations, right? Multiple locations, or you can say the branches. Okay, like if I'm talking about the bank, so bank also have multiple branches, and they won't communicate in that case from one branch to the another branch. And maybe we have multiple office as well. So just for an example, If I'm talking about, this is my one location. Okay, this is my one location, and here I have another location, site B. So here is site A for me, and here is site B. Okay, so now we have here ISP in between on every location, right? So there is an ISP device. So you can say this is the entire is internet service provider. That is internet service provider. Okay. So now that means if we have here entire network, the users are available here like this. We have here switch. Okay, and even we have here firewall. Okay, so this firewall is going to be connect with your internet service provider, or maybe any type of provider who is giving you connectivity to reach the public network. So here is the device of the ISP. And similar here also we have firewall 2 on this location, and we have here also switch, and there can be LAN users as well, right? So now in that case, here also we have internet connection, and there is the internet service provider, and these are the all maybe the mediator device of the ISP. Those are connected anyhow. Okay, so this is kind of connectivity here. And now we want to make communication from this site A to between site B. So the major point is here, we want communication from site A to site B. So maybe this is my private communication between these two sites, right? But this traffic is forwarding through the public internet. So what is the requirement here, guys? Just understand the requirement. So the requirement is need to make communication between the private networks over the public internet, right? Over the public internet. So in that case, we have two type of feasibility that we can provide. And what type of the feasibility? First think, we can make such type of ISP connection which can provide security by the ISP itself. Okay, and the second is we can configure security between our side by our engineer only. Okay, so in that case, like we have two type of connections, if you remember. The first one is we have some internet connections, or you can say ISP connections, not the internet connections, ISP connections. So the first IP connection is like broadband, right? So broadband is not something what we can achieve. Okay, broadband is just for internet access. Okay, just for internet access. So there is no any security for us. There is no security for us. Okay, and the second is lease line. Actually the difference in the broadband and in the lease line, broadband is giving you dedicated bandwidth. Okay, like in broadband you are getting like here 100 mbps link, right? That is 100 mbps link you are getting from the uh, ISP. Okay, so this 100 mbps link is actually your downloading speed. Okay, but uploading speed can be bit slow, not equal to the 100, maybe that can be the 50, because broadband is not giving you same speed for incoming and outgoing data, like what you are downloading and what you are uploading. So both speeds can be different, and you will face here like a lag as well during the internet access in broadband, right? But lease line is like your dedicated internet link. So these are dedicated internet links. Those are normally used on the offices, small offices, big offices, and even in the data centers, right? So these are the dedicated link, and in which we get the same speed for downloading and uploading, right? And uploading. and those links are given by a big and reputed organizations like Airtel, Geo, or maybe you will get from a mediator ISP as well. But they are giving you assurity and the services, like the link will be available for 24/7, right? So and the lease line is costly in that case. So at home we are using the broadband because if there is any problem in the internet, we can still manage these things, right? But in the office or in the data center, if there is a problem, so that will be a big problem because there will be a data loss, right? And there will be communication gap between the sites. So that's why we are preferring here lease lines. Those are giving you 24/7 support, and even the like availability of the link in that case. Okay, but these are actually public links. These are the public links, open link, okay, to access the internet. After that, we have here one type of VPN that is known as actually MPLS. So MPLS is like a private network, okay, private network which is offered by ISP to give a dedicated private link to you. So like lease line is like a internet link for me. If I want to reach anywhere in the world, I can use lease line link or I can use the broadband. But the difference is simple in broadband and lease line. Broadband is not much stable. That is only for home use, right? And lease line is dedicated links for offices and the corporate world, right? And MPLS is actually a private network by itself. Like using MPLS link, you can't reach anywhere in the world. Why? Because MPLS link is a dedicated link which is just for the private communication. And the example is here, like if I am running a organization which is non belongs to non IT, right? Which is belongs to non IT. In that case, we never manage the network by ourselves because we give the network to the third party. Suppose I am manufacturing here Audi cars, right? Or I am manufacturing the iPhones. So in that case, my main focus is on my product like Audi and iPhones, right? Not on network, how to manage the network, right? So I will give these things to a third party. And even the internet, we need a private communication only. We don't want internet access in that case. Maybe like one location is in Delhi and one location into the Bangalore, right? So in that case, we can have one dedicated uh, network for MPLS in that case, right? So MPLS manage everything for me. Like this is the task of the MPLS provider, who will exchange route from one site to another site through the network, and even giving me the security, even giving me security. Okay, so in that case, like we are now looking for security because in every case my traffic is going on ISP, my traffic is going on ISP. So I'm looking here for security, like how can I provide the security to my data in both cases, right? If I'm forwarding through the lease line over the ISP from one location to another location, and even in the case of the MPLS, so in that case we need here VPN. What we need here, guys? VPN, right? So now we need here VPN. So VPN is virtual private network. So this is used to provide, this is used to provide secure communication to private networks over the public network. So that means using the VPN concept, I can achieve the security even on the public network if I want to make communication between two private locations or between two private sites. Okay. So if I have here site A and here I'm using the site B, right? And here is the ISP network and both sites are connected with the ISP. So that means if any user is available here and want to make communication with site B users, so there will be VPN. So like my VPN is maybe initiating from the firewall, and maybe here I'm using the router. Okay, so now we have here VPN between these two sites. What we have VPN, right? So this VPN we are going to be used for the communication. Okay, now traffic will be passed through the VPN. So that means if I'm saying traffic will pass through the VPN, so this is now my secure tunnel. This is my secure tunnel where traffic is going through it, right? So if user one want to communicate with user two, so all the traffic is passing through the VPN. So this VPN is actually giving me encrypted traffic, or a traffic in which format which is not able to learn by a normal user, right? Okay, and now still the below network is over which network my traffic is going through, that is still public network, that is still public network. So over the public network, VPN is giving us a security to the data. So data will be in a such a format that is not in a readable format for a normal person if they try to capture the data and they try to like decrypt that data. Because here we have multiple features in VPN, those are going to make sure traffic is encrypted and that cannot be decrypted. Okay, so this is VPN concept here. Okay, so guys, in VPN now you need to understand, maybe you will see these two terms frequently. So when we talk about VPN, so there are two major technical terms. Okay, the first one is like underlay network, and the second is overlay network, right? So what is the meaning of underlay network actually? So underlay network is the network which provide the connectivity between the sites. Okay, this is this network is used to provide network connectivity between the sites. So who will provide you connectivity? Like if I'm using a lease line on my both location and location A and location B, so lease lines are offered by the ISP. So this is the responsibility of ISP who provide me connectivity between the both sites. Okay, so underlay network is actually like a public network for me. Okay, so in this case underlay is public network which is ISP network. So it's responsibility of ISP to make communication between the all the public IPs, because public to public IP have always reachability. If I try to make communication from like location Delhi to Bangalore or Delhi to in US, right? So still we are able to reachable to that location, because every country have public IPs, and public IPs are reachable to each other using the BGP, right? Because BGP is used to exchange the routes, right, on public network. So the underlay is the actual underlay network which helps you to make connectivity between the sites. Okay, and overlay is the VPN which is created with the help of underlay, right? So overlay, this is the network which is used to make communication between the private sites over the public network. So that means my overlay network is always able to make communicate with the help of underlay. So just try to understand. Firewall 1, firewall 2, switch, and the user, right? So suppose in that case, user have here IP 10.1, the gateway have IP 10.10, and here is 102.1.1.1, and here is 103.1.1.1, right, on outside interface, and here is just understand, this is 192.168.1.10, and here is 192.1 IP address, right? So now in both case we have two firewalls. This is my site 1 and this is site 2, right? So in that case we usually use here one default route on firewall, so it can reach to the ISP, and even this case also we are using here default route, so it can reach to the ISP. So in both case they want to reach to the ISP. Now the responsibility of the ISP, so ISP have here now routers, right? So these routers have maybe some routing protocol. Those are exchanging routes to each other. Like this route must be reachable to firewall 2 and this route must be reachable to firewall 1, right? So that means when ISP is giving you network reachability from site A to site B, so ISP is for me here underlay network. ISP is providing us underlay network, right? So if we have underlay reachability, then we are able to establish successfully VPN between the devices or between the sites. So now I can form here VPN tunnel, right? I can form here VPN tunnel. So this is my VPN tunnel now between the sites, and VPN tunnel is able to establish because of underlay network. So this VPN tunnel is now overlay network for me. This is overlay network, guys. Why? Because overlay network is established with the help of underlay network, because underlay is giving you connectivity, right? And once you have connectivity, you are eligible to form the VPN between the both sites, right? So this VPN is actually overlay network for me, and through that VPN now users are going to be communicate. So users are sending data through the VPN to each other like this, right? So this is now secure communication for me. So in that case, like in VPNs, if someone asks you about underlay connectivity, that means they are asking about the reachability of the underlay network. That means this public IP address of site A must be reachable to IP address of the site B, the public IP, because these IPs are routable over the public network. These are routable IPs, right? Because if like this network is connected even with the ISP here with this router, because the directly connected network, right? And this network also connected with the ISP router, and these ISP router are exchanging routes with routing protocols like BGP. So that is their problem, how they are exchanging the routes, right? We need reachability. Why? Because we have now dedicated lazy line link. So that's why we have connectivity, and once you have connectivity, now you can form the VPNs between the sites. So when we have VPN connection, or like we successfully establish the VPN between site 1 and site 2, so over the VPN we are eligible to exchange data. So that VPN is actually overlay network for me. That VPN is overlay network for me. Okay.
Please, Prof, explain that side again, just with the ISP and the VPN.
Could you ask again the question?
Yeah, yeah. I want to know the connectivity between the two sites via the ISP before the VPN.
Okay. Okay, let me explain you again with more detail. Host, we have here switch. Oh, let me write down like this. Firewall 2, and this is switch 1 on site 2, and these are the users. And now we have here ISP network. So just understand, this is the ISP network. Okay. Now In this ISP network, maybe we have here one ISP router, router 2, router 3, router 4, router 5. So maybe there can be any kind of connectivity. So just we are understanding like this, okay? Now both sides have internet connection. So here we have internet connection and here also. And here LAN network have IP 10.1, 10.2, gateway is 10.10, and here is 192.168.1.10 IP, 192.1, 192.2. Okay, the middle network is 168.1. Now we configure here always a net role on the firewall, because if you want to reach on the internet, and firewall also have here one default route if firewall want to reach to anyone in the internet. So similar we have here also default route, and even NAT if they want to reach to the internet, right? And these are the public IPs. Like here I'm using 12.1 as public IP on firewall 1, and here we are using 13.1 for an example. So now, so this is the entire ISP network. So normally ISP is using a combination of the protocols. The first they are using BGP to exchange the routing information. They also using here MPLS just to avoid to configure BGP on every router. Like if you know about routing and switching in detail, like CC Enterprise, so then you know why we are using MPLS also with it. And as underlay, maybe you are using ISIS or you are using OSPF, right? So these are the combination of protocols on internet. So we no need to worry about it what ISP is using. So the main point is here, if I'm using 12.1 IP, that means my network is 12.1.1.0 slash 30, right? So this is the subnet what I'm using, and here is the subnet is 30.1.1.0 slash 30, right? So my point is if my location 1 and location 2 is using these two public networks, so those network must be reachable with each other, right? Those must be reachable with each other. So that means my this network must be routable to this location, and this network must be routable to this location, right? And who is responsible to exchange these two routes? So ISP is responsible, because ISP also connected for the same network. So if I have here 12.ip on my interface, so here is 12.2 IP, right? And here is 13.2 IP on this interface of the router of ISP, right? So now this is directly connected network for ISP as well. So on this router, if route is directly connected, this is going to be advertised via BGP to these pairs. They are going to be exchanged to the next pair. So that how R5 is able to reach to this network, okay, via BGP. And similar R2 also able to receive the route 13 via BGP through the peer devices, right? Like 2, 4, 3, like whatever the routing configuration they are using accordingly. So that means both public networks are able to reach with the help of ISP. And after that, both sites are going to be formed here tunnel. Both sides are going to be formed here tunnel. So this tunnel is going to be connect both sides with each other, right? So that means whenever traffic is going through site 1 to site 2, traffic is forwarding from site 1 to site 2, that will pass through the tunnel. Actually this tunnel is even formed over the ISP network. So this entire ISP network is underlay network for me. Why? Because ISP is giving us connectivity from site A to site 2, okay? And over the underlay we have established the VPN. So this VPN is established over the underlay network, and this VPN is actually called as, sorry, oh, with the help of underlay network we have established the VPN, and that is called as overlay network, right? So these are the two technical terms maybe you will see, and even you will see these terms in automation, guys. If you talk about SDN, if any one of you know about SDN, SDN means I'm talking about SD-WAN, right? And I'm talking about here SD access. So SD-WAN also and SD access also using the same terminology, underlay and
Okay,
overlay.
Prof, my this thing is that one, firstly, if the ISP is already what's the name, passing the traffic or the route between the two sites,
Mm-hmm.
then why do they, that's if the two sites are already connected
Right.
via the ISP, then why
Uh-huh.
would they even need the tunnel in the first place? I'm coming, let me, before you answer me. The reason why I'm saying that is that, the ISP, most of the time, they can give you an internet connectivity for both sites, but they
Right.
will not give you a one connectivity for both sites. So then that's why you can employ your VPN across to be the overlay network above
No,
the underlay connectivity that they are giving you.
actually, ISP is giving us internet connectivity on my location, right?
Exactly.
So that
Yeah,
right now, even my laptop is connected with internet, and even you are also connected with internet, right? And
exactly.
still we
Yeah,
are able to communicate. So that means every public network is reachable from anywhere. Okay, so they have already advertised these routes through BGP protocol to everywhere in same country, in different countries as well, right? So that means public networks are already exchanged, and accordingly we are eligible to reachable from site A to site B successfully. Okay, but if they want to make communicate, they can communicate, but still this data is not secure over the internet. So over this internet, we have to establish our own VPN. So that VPN can provide us security. That is the main point. We are already connected on internet with everyone right now. But if I may,
exactly.
yeah,
That side, I get it. But my point is, even though you are connected, you can't be able to reach what's the name? The land side of the site
yeah,
B. That's if you are from site A, unless you have a VPN connectivity or a one connectivity via the ISP, maybe an MPLS or something.
right. You are right in that case. So that means still you can
So
reach
that's
to the
why
public IP only. You can't reach to the
yeah,
private IP because there are security reasons as well, right?
exactly.
Maybe
Yeah,
you can hit like the cyber threats as well we receive on the public IP sometimes, right? Like unwanted
yeah.
hits we receive, so we block them. So anyone can hit your public IP in that case, but they can't come to private network. So
Your
only
land.
like hackers can achieve these things. They know the loopholes of the network, right?
Yeah.
So in only in that case they can reach to the private network, but we have multiple security appliances and features to prevent these things.
Thanks.
Okay.
Yeah.
So my point was simple about overlay and underlay network here. Okay. So overlay is like VPN network and underlay is the public network for me in the case of VPN if we are asking about. So now I'm going to be discuss about here type of VPNs, types of VPN, right? And what type of VPNs do we have, guys? Okay, like in type of VPNs, we have major two type of VPN. One is known as overlay VPNs. I'm not talking about overlay network. I'm talking about overlay VPN. Okay, and the second is peer-to-peer VPN, guys. Okay, so let's come to the overlay VPN. Those VPN are configured by the customer. Okay, between the site. So that means if I'm talking about like I want security between two my sites, so in that case customer is going to be take care of those VPNs. Like here I'm giving you example of IPsec VPN, right? I'm giving you example of IPsec VPN. If I want to configure IPsec VPN between two sites, so those must be configured by me or by my team. Okay, so that is the uh, all management of your customer. So ISP is not going to be do anything in that case. So in the same example, if I have here site 1, and that is connecting with ISP and going to be connect with site 2. So here this is customer device, this is also customer device, and here these are the provider device. Provider means ISP device, right? So this VPN is between these two device, right? R1 and R2. So whenever VPN is between R1 and R2, so these are customer devices. So who is responsible to configure the VPN here? So customer is responsible in that case to configure the VPN, guys. Okay. So those are overlay VPN actually, and overlay VPNs are managed by the customer or configured by the customer, or you can say troubleshoot by the customer. So normally, like if we have any VPN, if I'm giving you example, we have some VPNs like I'm going to configure. Okay, if you remember from routing and switching, there is DM VPN in Cisco, right? Okay, and there is GRE. Okay, or there is site to site VPN. So those are the VPNs or remote access VPN. So these are overlay VPNs, guys, and overlay VPNs are always going to be take care by the customer only. So just provider can give you the reachability, provider can give you the reachability, nothing else. Okay, is that clear to everyone? What is the overlay VPN? Overlay VPNs are managed by customer only. Simple thing. Okay. And ISP is just giving you reachability, because ISP is again which network? Underlay network, right? But we have multiple type of VPNs. The second type of VPNs are peer-to-peer VPNs, guys. Those are peer-to-peer VPNs, right? So those are actually configured, or those are managed by the service provider. Okay, those are managed by the service provider for customer, right? So that means if there is any customer, so those customer network managed by the service provider. So like we had an example here, MPLS. So MPLS network is like a third party network for me. Like we can get MPLS link from Airtel, from Geo as well, right? Or from Reliance. So in every case, I need to advertise my prefix to ISP, and those networks are exchanged by the ISP from one location to the another location for me. So those are called peer-to-peer VPN, guys. And actually, these are some organizations. Those are actually non-IT organizations. Okay, so you can say like this is like manufacturer of bikes. Okay, like you know the Hero company, right? So maybe we have multiple plants of Hero company. Those are manufacturing the motorcycles. So we have one location in Delhi and one location in Mumbai, right? So in both cases, they don't want to manage the entire network by themselves. So they are going to be asked the ISP. So do you have any alternate or solution for us? So you can manage everything. So if I have here A network or B network, so we can simply advertise that network to ISP. Like in normal case, we never advertise routes to ISP, but this ISP network is actually MPLS. So MPLS is also known as private network, right? MPLS is also known as private network. So that means we are sending prefix to the private network. So maybe one device is here that is connected on our location, and one device is on ISP. Okay, and similar here. So we are using here, suppose some routing protocol, maybe we are using BGP, and we are using here OSPF. So from site A, we are sending route via OSPF to MPLS network. So MPLS network is sending those routes to in you can say different city, because one is Delhi, right, for me, and second is Mumbai. So the routes are advertised through ISP from location Delhi to Mumbai for me, and these routes are only visible into my BGP routing table on site B. So that means ISP will make sure if there are multiple customers like this, so they will not send one customer route to another customer because of security reasons. So everything is going to be managed by the service provider, because I am just advertising my prefix to ISP, and now the next call is ISP call. So ISP have to be make sure these site A route must be reachable to site B in that case, because we are sharing now private networks to ISP, or and that is only possible in MPLS case, okay, not in internet case. So that's why MPLS is private network for me. And even MPLS service provider make sure customer A routes will not be advertised to any other customer because of security reasons, because maybe multiple customers are going to be connect like this, right? So they have to be make sure one customer routes are not going to be advertised to another customer. So they are using here VRF concept, if any one of you know that, right? So every customer is part of different VRF and they are using here MPBGP, but that is not our thing to discuss here. So we need to discuss these things in enterprise network actually. Okay. So in this course, what we are going to be learn here, because I explained here two type of VPNs. One is the overlay VPN and the second is peer-to-peer VPNs. So we are only going to be discuss here about overlay VPNs, guys. And which are the overlay major VPNs we are going to be discuss? We are going to be discuss here about IPsec. Okay. We are going to be discuss here site-to-site VPN. We are going to be discuss here remote access VPN. Remote access VPN is actually SSL VPN, okay, or any connect VPN in the case of Cisco. So these type of VPNs we are going to be discuss here, okay, with multiple type of scenarios. So this is insecurity. So I hope that is clear to everyone what is our content that we are going to be discuss. Guys, is it clear to everyone till now, or is there any doubt? Any one of you? Okay. So I'm just discussing every small detail, like everything is from scratch. So I don't want there any doubt with VPN, because VPN is very important topic from a security point of view and even from the interview point of view. So first of all, I will try to explain you with just an overview of VPN, not in the detail. So first I will explain you with major details, right? And then we will go with the minor details as well, like in packet level details, what information is going in packet 1, what information is going into the packet 2, right? So now you understand what is the importance of VPN till now, right? What is the importance of the VPN and why we need it? So if this is clear to everyone, now I am moving with second point. And what is the second point, guys? What VPN provide us? Like VPN is giving us secure communication, but how? VPN is providing secure communication, but my point is how, right? So now VPN actually providing us four things, or you can say there are four pillar of the VPN. The first one is confidentiality. Second is integrity. Third is authentication. Fourth is anti-replay. So these are the 4 points. Because of that we are getting secure communication. So these are the four things what we are getting from the VPN actually. Okay. So now let understand every point in the detail how we are getting these things and what exactly the meaning of confidentiality, integrity, authentication, and anti-replay. So I'm starting here with confidentiality first. Okay. So confidentiality is actually, in that case, if user is sending any data from one location to another location, so that traffic is actually in a unreadable format for anyone on public internet. Okay, suppose my one user is sending data from one location to the location 2, so that data is actually still on public network, right? So anyone can capture your data, but after capturing the data, is it possible for that person able to see your data, what is inside the packet, right? And the every detail in the packet? No, that is not possible. So confidentiality is keeping your data confidential. So how it is giving you confidentiality? So in that, data is encrypted in a unreadable format. So that means whenever traffic is going through the network, so traffic will be put into a unreadable format for users, so they can't decrypt the data, right? So just try to understand, if we have here site A device and here is site 2 device, right? So now suppose user is generating the data, okay, and this data have, like, I'm sending here hello in this data. So whenever I'm sending this hello on a public network without encrypting it, so maybe any attacker is here in between, right? So that attacker is getting my data and that is going to be change it, right? Like, go to hell, right? Something like this. So this is inappropriate data according to R2. So whenever R2 is receiving, it will receive a manipulated data or wrong data, right? So that means whenever user 2 is receiving the wrong data, because that is changed by the mediator or anyone in middle, right? So we need to be make sure that data is going to be encrypt or going to be in unreadable format. So if anyone is receiving, they are not able to decrypt it in the actual data and they can't read it, right? So what we are achieving here with this thing, so whenever I'm trying to send hello, so before sending this hello, this data is going to be encrypted by my device, right? So that is going to be encrypted like in this format, in a hexadecimal format, or you can, sorry, this can be encrypted in any format, like this is the format. Okay, so this is my actual data. So whenever traffic is coming on any attacker this time, so attacker cannot decrypt this data because they don't know the algorithm and keys behind it. They don't know the algorithm and keys behind it, what are the keys. So accordingly they can't do anything. So the traffic will receive in exact format to the this device. So this device is going to be decrypt the data first and then going to be uh, actual data after decrypting. So it will process that actual data later, right? So that means confidentiality is going to encrypt your data in such a format that is not a readable for anyone, and even not the decryptable by the mediator device, because mediator device don't know what algorithms we are using, what keys we are using for the VPN, right? So that is confidentiality for my data, and we are using some algorithms to do this type of encryption. And what are the algorithms, guys? So these are the algorithms, if you ask about. We are using AES, DS, 3DS. So there can be more algorithms, but like AES, AES 256, these are the most used one. Okay, DS and 3DS is not used anymore because of some lack of security. Okay, so AES 256, 128, and these we are using as an confidentiality. So for encryption, these are the algorithms. Okay, so make sure remember these algorithms because we are going to be use these algorithm in VPN configuration. Okay, so that time I will just say for encryption we are using these things, and encryption means I'm talking about the confidentiality. So we will get the confidentiality in the data, right? So I hope the first point is clear to everyone. What is the confidentiality? And the second point is here integrity. So integrity means in this hash is calculated over the data, okay, and matched on both sides. Okay, so that means if my device is sending data, so before sending the data they calculate the hash value of the data, right? And after calculating the hash value, if that hash value is changed in between and other side also going to be recalculate the hash value, so if hash are different they are going to be drop the data, that means there is change in data. And if hash is same on both, and that means data is original, data is not changed by someone or anyhow. Okay, and here we have some algorithms, those are hashing algorithm actually. So hashing algorithms are MD5, HMAXA 256 and above, right? So these are the algorithms, those are used. So that means whenever traffic is generating from here, like we have here device, and this is the second side device. So now this is the data, so over this data they are calculating the hash value, right? So now when they are calculating the hash value, so hash value is like this in hexadecimal format: 0 01 A C D. So this is my hash value, and after this hash value the process of encryption, right? So first they are calculating the hash value, after calculating the hash value there is encryption. Okay, so this is like process: first hash value, then encryption. So after encryption of this entire data, so they are encrypting the data. So this is the encryption data. So when data is receiving on R2, so R2 is receiving this data. So first they are going to be decrypted, right? So when they are going to be decrypted, data will be received like this data, and here we have hash value of the data. And once we have hash value here, so this R2 is going to be calculate its own hash value using the same algorithms what we have configured on both end. So algorithms are configured identical on both end. Okay, then they can negotiate and calculate the hash value. So if this also getting the same hash value like this, okay, so then it's going to be matched with the value what is received in the packet. If both are same, that means data is original. Data is original, that means there is no change in the data, or there is no like data is not altered. If like this hash value is wrong, if this hash value is wrong, something like this, so that means both are not same. So the device is going to be drop the data, device is going to be drop the data. So the reason is here because of different hash value. And even all the things are working together like hashing and encryption, and there are more things. So they are like no chance of altering the data. Okay, is that clear to everyone, guys? Okay, now the next point is authentication. Next point is authentication. So in this case, both sides are going to authenticate each other, right? So they authenticate each other. So accordingly, they will verify, okay, this is like authorized device or site which are going to be negotiate for VPN with me. Okay, and how they are going to be authenticate? The first thing is pre-share key. So we can define pre-share key means like this is configured key on both end, right? Configured means like pre-share key. So we defined the same key on both end, right? And the second, there can be like some certificates, so we can use some digital certificates for the authentication purpose also. So we can use both of them. Okay, so right now we are just talking about the pre-share key. So that means if I'm using the both locations, R1 and R2, now I'm going to be define my pre-share key like Cisco on this device and Cisco here also, right? So now this is my data. So first of all, device will calculate integrity. So this integrity is now on data plus pre-share key. Okay. So now we have here hash value of the data. This is the hash value, right? After hash value, the device is going to be encrypt the traffic. Device is going to be encrypt the traffic. So that traffic is now. So this is the encrypted data. And after the encryption, that means like both devices have same key. So using the same key, they are calculating the hash value and sending data here. So now data is received here. So now the first they are going to decrypt the data. So when data is receiving here with hash value, okay, so this is now like hash value what they are receiving. So the device is going to be calculate its own hash value, but this hash value also with password Cisco and data. So if the device is getting same hash value in that case, so that means this is original data. So even they are using the pre-share key, right? So pre-share key also used to calculate the hash value. So like there are multiple things that working together to give you the assurance of security, right? So is that clear to everyone? Okay. So if this is clear to everyone, the next point is anti-replay. So to prevent the anti-replay attack, the device is using the sequence number, okay, random sequence number. Okay, let understand this, guys. So the fourth point is anti-replay. So this anti-replay attack means like there can be such type of attack. What is the meaning of that? Let me explain you something. If device is calculating same hash value, right, each time, so it will be easy for attacker to get the key value from hash, because if my device is calculating same hash value, like my data is here, right, so on the basis of data, device is calculating this hash value. This is the hash value. So for every packet, hash value is same. So that means if my hash value is same, after some time, maybe like after 1 hour, 2 hour, attacker can calculate the key, like what key I'm using. So attacker can calculate the key on the basis of same hash value, using the same hash value. So that means I need to change this hash value of in every packet, so it will be not easy for attacker to get the original key, right? So in anti replay, to prevent this anti replay attack, the device is using the device is using random sequence number in each packet. So if there is random sequence number in the packet, so every time there will be a different hash value, right? So every time in every packet there will be different hash value, okay, and it will be not easy for a attacker to get the key in that case, right? Are you getting the point? So these are the four things, guys, that we are getting in the VPN. Confidentiality, which is actually encryption, like they are using VPN is using encryption algorithm, AES, DS, 3DS, right? And in integrity, device is calculating the hash value over the data, and that hash value is calculated with the help of MD5 and HMAX algorithm. And in third point, we have authentication. So device are also authenticating each other using the pre-share key or digital certificates. And the last one is the anti-replay, which is prevent with the help of sequence number, because of random sequence number in every packet. So these are the four things that we are getting with the help of VPN. So that's why we say VPN is giving us secure communication over the public network, So if anyone have doubt in these 4 points, let me know. Is that clear to everyone? Okay, great. So now let's come to the actual VPN things. So now we are using here, or we are talking about here, IPsec. So what is IPsec in full form? It's like IP is internet, right? Internet protocol, and sec is security. So we are giving security to the internet protocol, to the IP, because IP is like the IP which is communicating from one side to the another side over the internet. So that is IPsec. So IPsec is a protocol suite which is using multiple protocols in it, or multiple things to secure the communication, right? And IPsec is actually using here one protocol that is used to give secure communication, that is used to secure communication. So I'm just giving you an idea like what I'm trying to explain. So in ISP is using, sorry, IPsec is using ESP protocol. ESP actually stand for encapsulation security payload. Okay, so this is actually a layer 3 protocol which is using protocol number 50. Okay, and this protocol is actually used to transport user data. We are talking about here user data security, right? So this protocol is used to share the user data from one site to other site in encrypted format, right? In encrypted format. So I'm just telling you about the user data right now. Okay, I'm not talking about how VPN is going to be formed, because we need to understand the requirement, and accordingly we will understand the things one by one. So if you remember, we have here one device, you can see router or firewall, ISP, and here is R2, right? So that means if any user is here connected with the device and the second user is here, so when the user is generating the data, so that data is like, it can be like ICMP layer 3, it can be any HTTP data or HTTPS data. After that the device is going to be add here IP addresses, right? 102.1, 103.1, right? So that means now source IP is 102.1, destination is 103.1. So these two information are the IP details are here, because when the device is moving to the public network, so they need public IP address. So maybe the device is doing here net, right? Maybe the device is doing here net, or maybe because of something else, right? So when traffic is coming on the data, so this device have responsibility to use ESP protocol. So like now when traffic is hitting on the router on this interface, so like let me write down again the IPs. Here host have 10.1 IP, and suppose here is 192.1 IP. So source is here 10.1, the destination is 192.1. Okay, so now the traffic is forwarded by user to the router, so router is receiving before exiting it. Okay, so device is now we have here secure tunnel, right? So secure tunnels means now traffic will encapsulate in this protocol, so that can be sent with security to other locations. So now data is here, and that data is going to be encrypted with the help of ESP protocol. Okay, so above data we have ESP to encrypt the data, and that ESP is using now public IPs like 102.1, and second IP is 103.1, right? So that means this is entire is encrypted data. This entire is encrypted data for us, right? So I'm just giving you idea on the behalf of user data, how user data is going to be forward. So internet is giving us a protocol ESP. So ESP is now going to be take care of everything. So this is when your tunnel is established. This process is when tunnel is established. So just I'm assuming my tunnel is established between the devices. So now user is able to forward the data using the ESP protocol. So ESP is going to actually encrypt your entire data. Like there are multiple algorithms. On the basis of algorithm there are some keys. So keys are generated by the devices in this VPN process. So those keys are used to actually encrypt and decrypt your data, and then they add the ESP header on it, right, just for the security of the data, and then forward it over the uh, public network. Okay, but now before discussing about ESP in detail, we need to understand how this VPN is going to be formed and how the devices are going to be exchange the keys, like how these keys are going to be generated, right? So for that, we have now here one thing, or we need to understand what protocols are going to be used in the process of VPN or in the process of IPsec. So I can say IPsec. So this is protocol suite which have multiple protocols, or you can say which have a framework to decide the, which have framework means like how they are going to be do everything in VPN, right? Decide the VPN key exchange and the protocol types, right, which protocols we are using in it. So IPsec is using the below protocols. So these protocols you will hear in IPsec configuration. The first is like IKE, okay. Second, you will see about ISA camp. Third, there can be ESP protocol, right? So there can be more. So just for now, let's start with this, okay. So just IPsec is a name, but behind the IPsec there are protocols. Those are working. Like if you talk about a organization, so organization is a name. There are multiple teams, multiple people, right? Group of people. Those are working for that organization, right? So we need to understand those things in detail. So first is IKE. What is IKE, guys? Internet Key Exchange Protocol. Okay. So this protocol is actually used to negotiate and establish the secure site to site and or you can say the VPN between the sites. So this protocol is used to negotiate and form the secure tunnel between the sites. So that means whenever we are talking about VPN, so VPN is because of IPs, IK, right? So IK is the protocol which negotiate how they are going to be exchange the keys and which algorithms are they are going to be used. Okay, so that is all because of IK, and IK is also called as ISA camp in Cisco case, right? So that means in Cisco document they are giving you reference of IK and also ISACAMP, right? So both are protocols, or you can say separate things, but in Cisco they are using both as the same protocol. Okay, the thing is, IK is giving you few things, but ISACAMP is actually the medium through that device exchanging the information. Let me explain you what is ISACAMP here. Then you will get idea the actual difference, or like what IK is doing and what ISACAMP is doing in IPsec. Okay, so ISACAMP is Internet Security Association. Key management protocol. Okay, so this is UDP based protocol. This is UDP based protocol, and it's using port number 500 and 4500 in case of NAT traverser. So what is NAT traverser? We will discuss. Normally ISACAMP use port number 500 and 4500 is when they are using the NAT traverser. Okay, we will see what is that. And ISACAMP is actually giving you these features or things, okay, in IPsec. So key exchange, if I want to exchange the keys between two devices, that is possible because of ISACAMP. Okay, key exchange, or you can say the keys generate first. Okay, then it's going to be exchange the key between the peers, okay, using the packet of ISACAMP. And after some times device also refresh the keys, so those keys are going to be exchanged again, that is rekeying process. So we can say rekeying also through the ISACAMP protocol. So ISACAMP protocol, these tasks. Okay, so that means if I have two routers or two devices, okay, so in between these two devices, if I want to establish the VPN, if I want to establish the VPN, so ISACAMP is actually giving the transport. This protocol is giving the transport. Transport means ISACAMP have packet types. Those are help to exchange the keys. Those are help to exchange the keys from one peer to another peer, right? So they will explain you what algorithms you are using, how to calculate the keys. So everything we can exchange with the help of ISACAMP packet here. So ISACAMP is here transport, okay, because like we know everything with the help of IKE. Okay, so IK is like giving you the things how you can exchange the keys, how to generate the keys. Okay, but these everything is going to be done by the ISACAMP, because IK is just giving you ID and the process, but ISACAMP is actually going to be initiate these things between the peers, right? Okay, so that means these both protocols are working together here. So like if IK is giving you entire process how to do that thing, so those are done by the ISACAMP. Those are done by the ISACAMP here. Okay, so you can say, let me explain you few things. ISACAMP, so ISACAMP have framework to exchange the keys. That means ISACAMP know how to exchange the keys. So ISACAMP know the entire process how to sorry, like you can say ISACAMP knows the framework how to exchange the keys, right? So ISACAMP is giving us transport. Okay, and ISA camp also giving us phases. Okay, phases of IPsec, phase 1 and phase 2, right? But IPsec, or sorry, IKE protocol, IK is giving us idea like how we can exchange those keys. Like ISA camp know I have to exchange the keys and I have header to exchange the keys, because ISA camp is a proper protocol, UDP based protocol. So ISA camp have header to exchange those keys, right? But ISA camp don't know how I have to exchange the keys, like what will be the process. Like I have to exchange these keys first, those keys first. Okay, so IK is here giving you framework to exchange the keys and define the modes of IPsec. Okay, define the modes of IPsec and also define the framework to exchange key. Okay, so these things we are getting with the help of IK. So IK actually have these modes. So these are the modes, guys. We have main mode, we have here aggressive mode and quick mode, right? And ISA camp is giving you phase. So we have total here two phase 1 and phase 2. So that means ISA camp is giving you idea I will divide all the process into two phase 1 and phase 2. And IK is giving you the modes like main mode, aggressive mode. So in these modes IK is giving you number of the packets, how many packets you have to be exchanged in phase 1, how many packets you have to be exchanged in phase 2. Okay, so that how you can categorize the working of ISA camp and IK here. Is it clear? So now let's understand what is the work of phase 1. So phase 1 is, this is giving a secure path for phase 2. That means phase 1 is a creating a secure path for phase 2 and also giving authentication. So that means that device or peer must be authenticated. Like if we have VPN configuration for R1 and R2, so both routers must authenticate with each other, right? Both must authenticate with each other, then they can trust on each other to form the VPN, right? And phase 2 is actually giving secure path for user data. So this is generating a secure path. Like secure path is already created in phase 1, but phase 2 is exchanging keys to make a secure tunnel for user data. Exchanging keys to make secure path for users. That means phase 2 is giving you a secure path again, right? But this secure path is for user data, and phase 1 is giving secure path for phase 2, because phase 2 is important, because in phase 2 you are exchanging some keys, and these keys are used for user data here to encrypt and decrypt
Oh,
the user data.
sorry to cut you. So please, I need your like more like a
Hmm.
clarification here, like in two lines or in two statements.
Phase 1 and
IK and Isaacam.
okay.
What's the main difference? I mean, I'm thinking about one being an encryption algorithm and the other one being the the transport of the tunnel.
Okay, you are asking about the difference between
The
ISACAMP
main
and IKE,
difference
right?
between, yeah, because up to now I'm still confused.
Okay, actually, IK is giving you an entire framework. Like framework is, we have these keys. That how you can generate the keys. But IK don't have actual transport. How to exchange the keys between the devices, and how many data we can transport, right? So those things are given by the ISACAMP. So ISACAMP is a protocol. So whenever devices are exchanging the information, so that means if router 1 is here connected with router 2 over the ISP network, okay, so that means whenever R1 sending the key information, so here we have keys, right? And these keys are because of IKE, because IKE help you to get the keys.
Decode it when you get to the other side.
Yeah, other side I'm explaining, wait. So IK is just giving you entire the framework, like when you have to be generate key, what process you have to be used. So these entire data is going to be exchanged with the help of ISACAMP. So ISACAMP is the transport here, right? So this is
Okay.
giving you transport mechanism. And ISACAMP also deciding, like IK is saying I have total 6 packet in main mode, I have 3 packet in quick mode, right? So there are total
Yeah.
9 packet. So Isaac Amp is saying I have two phases, phase one and phase two. So in phase one, I am going to be exchange your 6 packet of main mode, and in
Mhm.
phase two, I will exchange your 3 packets of quick mode. So that means Isaac Camp is giving the idea how I can exchange how many packets of uh, main mode, and how many packets I can exchange in phase 2 of the quick mode. So the modes are decided by IKE. So IKE decided we have main mode 6 packet, quick mode 3 packet, right? But these 9 packets are exchanged according to the ISACAM process. So like these are two different protocols, you can say, and both have its own working, but they have even dependencies on each other. Like one is giving you, okay, let me explain you, maybe this will give you the idea. So we have here IKE. So IKE is saying I have three modes, right? One is the main mode, and main mode have total 6 packet, right? And there is one is quick mode, okay, and quick mode have 3 packets. So there are total 9 packets. So IK defined the 9 packet and what detail will be in the packet, right? The details, the packet data is defined by the IK. But IK don't have any header to share that data with other protocols. So they don't have any header, right? So Isaac Amp is here. Isaac Amp is saying, okay, I can transport your data, but I will say how many packets I will share in my phase one. I will decide that by myself, right? Phase one is saying it will exchange only main mode, main mode packets. Those are the 6 packet, right? And Isaac Amp is saying in phase two, I will exchange the quick mode packets. These are total 3 packets, right? So like phases are part of Isaac Amp and the modes are part of IK.
Yeah, I get you now.
Okay, so that means like
Yeah.
IK defined the process, IK defined the key mechanisms, how like key mechanisms means like what will be the algorithm and the other things. So using those parameter, ISACAMP will generate the keys, it will generate the keys, right? And those keys will be put inside these 6 packet, and those 6 packets are exchanged through the ISACAMP protocol in phase 1. I will come in the detail of phase 1 as well, what is the exact data is exchanging in phase 1 actually, okay.
All right.
So for now we are just understanding the concept of phase 1 IK, or you can say ISACAMP, right? Like if you just wait a minute. Okay. See, so IPsec use IK protocol to negotiate and establish the secure tunnel or remote access VPNs, right? And IK protocol also called Isaac Camp in the case of Cisco sometimes. So if you want to go in the detail of IK version 1, so we can go through the RFC that is on the internet, and later we will discuss about IK version 2. So if you go with IK phases, so we have total two phases. So those are actually ISACAM phases, right? Separate into two phases. And what is the task of phase 1? So phase 1 is the two ISACAM peer establish a secure and authenticated tunnel which protects ISACAM negotiation meshes, right? So that means the phase 1 is creating a secure tunnel for phase 2. For phase 2, so that means phase 1 and phase 2 are under your ISA camp, right? And the modes are defined actually in the IK. Modes are defined in the IK, right? So that means IK and ISA camp working together. And in the case of Cisco, you can say IK is like ISA camp protocol also. Okay, but IK don't have any header or transport mechanism. So whenever packets are exchanged from one device to another device, you will see ISA camp header and you will see UDP port number 500 or 4500 in the case of net traversal, right? So you can categorize accordingly, like what you are exchanging, what not. So in phase 1, Isaac Camp is saying I will create a secure tunnel. For phase 2, and I will do authentication. So that means both router can make trust on each other. That is the meaning of authentication here. Okay. And secure tunnel means like this is secure tunnel. Over this tunnel, they can exchange the phase 2 data. And this phase 2 data is like key negotiation and algorithms to encrypt the user data over the IPsec tunnel, right? So that means actual user data is exchanged over it, right? So for that they are creating ISACAM secure tunnel, and after that they are creating here user data plane. Sorry, they are creating the tunnel for user data, and for that they are using ASP protocol, right? Okay. And if you talk about the modes here, see, IK mode in phase 1, we have main mode, right? And we have aggressive mode. So in phase 1 we have two modes. Phase 1 have two modes, guys. So remember, phase 1, phase 1 is secure the, phase 2 and authenticate, right? Authenticate the peer. So these are the two tasks of phase 1. And phase 1 have two modes under it, main mode and aggressive mode, right? And if we talk about phase 2, phase 2 is used to create a secure tunnel for user data. Create a secure tunnel for user data, right? And it have just quick mode, right? So that how they have separated. And main mode have 6 packets, and that is actually used in normal IPsec. Okay, normal IPsec configuration. So we use here main mode. Aggressive mode is only used in the case of remote access VPN, and it have 3 packets only, and that is used in remote access VPN. Remote access VPN, you can say like any connect VPN of Cisco. Everywhere, every OEM have their own VPN in that case. Okay, and this is using 3 packets, guys. I'm explaining these type of packets with IKE version 1. If I go with IK version 2, the number of the packets will be different. Okay, number of the packets will be different, but still information remains same. IK have some challenges, so those are mitigated in IK version 2. So firstly we will come with IK version 1, then we will talk about IK version 2. Okay. So guys, do you have any doubt till now? Everyone? Kenil, Vicky, Vidya.